All right, so last time we talked about the layers of the earth and the mantle being bendable rock and the crust being, basalt and granite and things like that. So what does this have to do with plate tectonics? So we've got two things that we need to talk about. The lithosphere and the asthenosphere are the two types right there. The lithosphere is the outermost rigid layer of the Earth's of the Earth, which is called the lithosphere. It's made of two parts, the crust and the upper part of the mantle. So it's right in here. And then the asthenosphere is right underneath the lithosphere. So if you look at this right here, the lithosphere is right here, and underneath it is the asthenosphere. So that's exactly what we're talking about today. So this is kind of another way to divide the Earth. The lithosphere, litho means rock. This is a solid, rigid outer part of the Earth. It's made of the crust and the upper part of the mantle. It's about 100 kilometers thick, and it's broken into pieces called tectonic plates. So if anybody tells you, oh, the tectonic plates, they're on the crust, no, they're actually on the lithosphere, which is part of the crust and part of the mantle. So they're not correct when they say that. The asthenosphere is underneath it. It's a soft layer of the mantle, kind of like hot plastic, or you could think about it like jello or something like that. It's made of solid rock that moves very slowly, and tectonic plates move on this soft layer. So because of the asthenosphere, that's why we have those plates moving, hitting each other, sliding past each other, and things like that. So you can think of it as the lithosphere is the boat, and the asthenosphere is the water that allows that boat to kind of move. It floats on top of it, and it moves and kind of bumps into other things. So make sure that you write that down on your notes, that the lithosphere is the boat, the asthenosphere is the water. Now, when we're talking about the lithosphere and the asthenosphere, we actually have to talk about heat transfer, because that's what's going to cause the asthenosphere to kind of move and bend and also cause those plates to move. So the first one is radiation. This is heat from the sun that can travel through empty space. Conduction is through touching. So if you touch something else, that's hot. So if you touch a stove, that is conduction. And convection, this is very, very important, because this is the one that has to do with the lithosphere and the asthenosphere. This is when heat moves through fluids, like the mantle, where it's, that bendable rock, that jello stuff. The heat will come through there and it'll fall back down in kind of like a current-like motion. The warm air that is less dense rises, and then of course the colder air sinks. All right, so this is how convection currents work. Whoops, hello. Heat comes from the core, so this is where a core is, and then heat rises to create currents due to density differences. So all this heat is going to come up, is going to hop on this little train right here, and it's going to come up towards that lithosphere, and it's going to cause those plates to kind of stir a little bit because they're heating up. And then it's going to fall back down, it's going to get heated back up again, and then it's going to cause the plates to move, and then it's going to fall back down, and then it's going to heat back up again, and it's going to cause those plates to move, okay? So because of convection currents, that is why we have those tectonic plates moving, creating volcanoes and earthquakes and things like that. All right, so some questions for you. List the 4 layers of Earth in order, beginning with the surface. You should have the crust, the mantle, the outer core, and the inner core. In general, how does the density of material in Earth's layers change with depth? Does it increase or does it decrease? Of course, it increases with depth. In Earth's crust, what type of rock is found under the ocean? The ocean, that would be oceanic basalt. The thickest layer of the Earth is the mantle. And what state or phase of the Earth's inner core is it? That would be solid. Make sure you know that. And again, this is another picture of the lithosphere and the asthenosphere. Of course, the lithosphere floats on top of the asthenosphere. That's why it says solid and partially molten. And here are the plates that we have on the Earth. So it's divided into 10 major tectonic plates. And you need to know the continental ones and the Pacific plate. So the Pacific plate is number 1. That is this one right here. And think about what might be around here. If you see all of these kind of landforms in here, this is called the Ring of Fire, if you haven't heard of that before. Number 2 is the North American plate, which is where we live. And then we've got the Cocos plate, which is right here, the Nazca plate, which is right here. The South American plate is over here, African plate over here, Eurasian plate is right here, which is a really big plate. The Indian plate is right here, the Australian plate is over here, or it goes over here as well. And the Antarctic plate is all down here, very big plate down there. Okay. All right, so this one right here is where we live. You definitely need to know that. That's the North American plate. All right, tectonic plates are usually made of oceanic and continental crust. We already know about this. And the last thing that we're going to look at is California. So we have the North American plate right here and the Pacific plate over here. And they are actually moving in opposite directions. We actually call this a transform fault. And it's because it's moving from this place and this way, so it's sliding past each other. And right there is actually called the San Andreas Fault. There's a movie that just came out. I haven't seen it yet. I don't know if it's good or not. But it's actually about California breaking off because California is actually half on the Pacific plate and half on the North American plate. So yes, eventually it will break off. Don't know if it's going to happen in our lifetime, but those plates are definitely moving, and it's causing a lot of earthquakes over there if you've ever been over there. All right, use the following link to introduce plate tectonics. We're not going to do that, blah, blah, blah. All right, which of the following compositional layers makes up the greatest percentage of Earth's mass? Continental crust, oceanic crust, the mantle, or the core? So which one has the greatest percentage of the Earth's mass? That would be the mantle. All right, make sure you got your notes filled in. Any questions you need to write off to the side, and make sure you bring it to class tomorrow. We will see you then.